Meet Jeremy. Jeremy is an electrical engineer living in San Francisco. By day, he works on building the appliances of the future. At night, he puts those appliances into practice. Jeremy has built what many would consider a smart home, which he has aptly named Jeremy's Astute Residential Virtual Intelligence System, or Jarvis. Jarvis has control of the vast majority of Jeremy's home appliances. She can dim or raise the lights, play music, and open and close the window curtains. While Jarvis is not yet to par with the comic book character she was named after, she represents a growing group of people making their homes smarter and more efficient with their own work and ingenuity. Thanks to the rise of the small yet powerful computing hardware like Raspberry Pi and Arduino, and the proliferation of open source mobile OSs like Android, the technology currently exists for individuals to build the networks and infrastructure that allow a home to sense, think, and implement strategies that can increase comfort and decrease energy costs. And the best part is, they can be built exactly as you want them. This type of home-built technology is part of the greater trend to turn our traditional home systems into smart home systems, which utilize electronics, computers, to account for human error in maintaining the home environment. A smart home implements greater security systems that can better recognize residents from strangers, electricity monitoring to prevent unnecessary waste, and heating and cooling systems that only work when they need to, among a variety of other creature comforts that can provide greater ease of living. Homes like these come at a perfect time in our culture's shift to more energy efficient and environmentally friendly alternatives. Estimates suggest that residential systems consume 36% of the total energy production in the US. Of this, up to 15% of our energy use is due to inefficiencies. While we keep lighting and heating on in rooms that we are not using, and keep electronics plugged in when not in use, we are letting money needlessly go up in smoke. Currently, heating and cooling and lighting are the two greatest draws of electricity in US households. With smart home systems, we hope to bring these costs down substantially. As a result of this energy consumption, 12% of US CO2 emissions are the result of residential energy demand. Of this, 81% is the result of natural gas burning for things like heating and electricity. Environmental degradation is a significant issue that results from emissions like this, with globally spanning potential ramifications. Any little adjustment that can be made that has a net positive effect on reducing pollution should be taken when available. Already we are starting to see the implementation of these sorts of technology. You may recall the kilowatt, which monitors energy use and displays it via an LCD screen. Already we're beginning to see something even greater: Bluetooth-enabled electricity usage monitors, which can wirelessly transmit energy usage data to another device like a phone, watch, or laptop. We are right now able to remotely keep track of how much energy we are using and switch on and off appliances to reduce energy loads when we are not home. It gets even better, too. The advent of modularity may also factor into the user-driven smart homes of the future. Phone blocks was a concept imagined 2 years ago, which proposed interchangeable modules that can be swapped between phones, laptops, and eventually home appliances. Project Aura, designed by Google's Advanced Technologies and Projects team, is the realization of that idea. The Google team is working to create a modular system that will allow users to connect their phones with their washers, their refrigerators, microwaves, cars, and more. They envision an entirely integrated system, which continually downloads and updates the preferences of the user and adapts their functions to suit them. Another perfect opportunity for tinkerers and home engineers: thermostats are now capable of learning our routines and adjusting our energy consumption accordingly. Imagine in the near future, when your watch is able to keep track of where you are in your house and create so-called heat maps of where you are throughout the day. This way, if your home is appropriately outfitted, you can selectively heat only the areas where you'll be without needing to heat the entire house, potentially saving thousands in heating costs and reducing the need to heat as much at once. It's not as if the idea of smart home technologies are out of reach. Already, a good portion of U.S. households have access to technologies like those previously mentioned. Currently, 17% have some form of wireless speakers, and 1 in 10 households have access to either a smart thermostat or a remote home monitoring security system. Other homes have things such as domestic robots, such as your Roomba, smart lighting, such as LEDs that can adjust the color and warmth of light and have significantly longer lifespans, smart locks, smart refrigerators, smart laundry machines and washing machines. The list goes on. These numbers are expected to increase dramatically with time. Altogether, these advances are part of a growing network of connected devices that increase the availability of data and communications necessary to improving our global infrastructure and our global livelihood. The Internet of Things, as it is often called, is the sum product of what technology has to offer us. Smarter home technologies allow our electronics to communicate, share information, and provide far better services to us. As the environment around us becomes more intelligent, we can expect to see improvements in both environmental sustainability and cost effectiveness. My name is Will Neds. This is a presentation for BSAD 147 with Thomas Chinden on smart home technology. Hope you enjoyed it, and if you have any questions, be sure to comment on the discussion board to which this was posted. Thank you very much. Have a good day.